Well, overall, I think we have a success. Well, we have the rig partially set up. I am missing a 3-wave diverter valve that I would like to have in here, basically so that we can send the water from this little settling pond either to the drill rig, or I'd like it to return back to the settling pond when I am connecting and disconnecting lengths of the drill pipe. For now, I just have a T and a valve there. We're going to start with a pump test just to make sure that we can get circulation going from our little strainer through the pump up through the rotary swivel, come down the pipe, and then return back into the pond. Well, that didn't quite go as planned. I am soaked. So I was priming the pump, I had the little cap off and I just had it idling, and then it suddenly just started to suck like crazy and the geyser just started pouring right out of the fill hole there, and now I am all wet. We got a ton of water everywhere, but it's working. Alright, so we got our setup here, we got our bypass closed, we got some good flow coming through, and you can see that's exactly what we want to be going on here. So all of our cutting water is just getting returned right back to our pond. A little bit of a vortex occurring in there. Have to figure out a way to disturb that water so that we don't get air going into the system. And this is a good sign. We got a couple PSI of pressure there. So our circulation test is complete. Thumbs up, it worked well. I wish I had that 3-way valve. I'm gonna see if I can come up with something just so that we can get going here, not be waiting on that. It may not even arrive for the next couple days, and I just don't have time to spend sitting around waiting for that. So let's see what we can come up with, and see if we can start drilling this hole. Well, it's a little janky, but I had this elbow that had these 1-inch threaded couplings glued onto, and it just acts as, I needed a nipple. I needed like a 2-inch nipple, but this will do just fine. So I have one valve here that goes to the swivel, that one's the return, so it's just a matter of opening one, closing the other, and vice versa. The sun is out, we're ready to go. Let's see what this thing can do. Yeah, of course, just as we start drilling, a little squirrel starts to pass by, so much for that sunshine that we had. Hopefully though, it will be short-lived and we'll get back into that blue sky over there in a couple minutes. Well, it's day 2. We really didn't put in a full day yesterday. We got about 4 hours of work done. So that was the setup of the rig, and we did a little bit of drilling. We made it to 56 feet, and today I'd like to double that depth and put all the pipe we have into the ground. Overall, this is our setup. I have our drilling machine set up basically over the borehole where we were working yesterday. Basically the same setup today. Really the only difference is that yesterday we were running a single pump to circulate water basically through the mast down the borehole to lift those cuttings up and deposit them in this settling pond, also known as a kiddie pool. So for today, we've added a second pump in series with the intent that that will help with this first one. So we were getting to about 20 psi yesterday when we were at the 56-foot depth mark. Now, these pumps are not ideal for what we are doing, but they play a massively important role in the whole operation. I'd say 99% of what we have going on here has to do with the pump, and so it's the pump's ability to provide flow to lift those cuttings up that annulus in the borehole and keep the drilling fluid circulating so that it doesn't get plugged up. By having 2 of these in line, they should basically share the load. We're not going to see any improvement on flow, maybe just slightly. We're not going to see a dramatic improvement on pressure, but what it's going to do is just share the load between the 2, so as we go deeper, the one little pump isn't going to be stuck chooching its little heart out to try and make this work, so they'll both kind of share that role equally. This is what we were able to get out of the ground yesterday with that 56 feet, a couple cubic feet of basically it's just Red River clay. That's it. That's all we've had to deal with so far. Hopefully we can get down to the 120 foot mark without really any dramatic changes. That would be ideal for what we're trying to do here. And yeah, overall, working really well. So I mentioned that the pumps are working great, and so is our rotary swivel. We've had 0 leaks, not even drips from around the seal, so that's working absolutely beautifully. Our DC motor is working really well also. So on the control box, I have a variable speed controller here, basically from 0 to max speed. And it's also reversible, so I can advance the bit or the threads down into the next piece of pipe or back them out. And on the display here, it's basically just giving me 2 pieces of information. Voltage that's going to the motor, not super important, but the important piece is the current that we're sending to the motor. So right now, as we're drilling, we are seeing anywhere from 0.8 up to 1 amp of current going to the motor. And based on the motor and this 30-to-1 gearbox, that works out to somewhere around 2 foot-pounds of torque. Incredibly small amount of torque to actually do this kind of work, which is pretty cool. So like I said, it's the pumps that are doing all the work. 99% of what we're doing here has to do with the pumps. That gives you a little bit of an idea of how this is working out. We're going to get everything set up. We're going to get the pump started, and we're going to try and drill down to 112 feet. That's the pipe we have right now. So for our drilling that 3 1/4 inch hole down to 60 feet, this is what we managed to clear out of the hole today. That is what was in the hole from yesterday. So overall, I'm gonna say we're probably maybe around 1/3 of a yard in total. There's not a lot here. Gotta keep in mind that it's only a 3-inch hole, 60 feet long. Well, overall, I think we have a success. Although we didn't make it to 100 feet, we only made it to about 60, and then we hit some harder gravel-like material. I'm not gonna give up quite yet, so there's a couple things that we could do to improve our chances of making through that layer. And one of those is, of course, a smaller pilot bit. The other one is the pump. It's just not able to lift those heavier cuttings up to the surface like I'd like it to, and I think that could make a big difference in clearing the hole from some of those gravels that we're running into right now. Like I said, I'm gonna call this a success. Let's say a passing grade anyway, 60% out of 100. Well guys, I hope you've enjoyed this series so far. For me, it's been incredibly interesting working through all the different challenges of building a rig like this. And I know a lot of people have been curious, what is the purpose of this? Some of you have gotten really close, thinking that it's maybe for drilling a well. You're not far off. We are boring a hole into the earth, but the intent is not to get water from the earth. I'm hoping to drill down to at least 120 feet so that we can install a geothermal ground source heat pump. Now, that's something that I've wanted to install in our household for many years. Unfortunately, the drilling costs and installation costs of the ground loop are a significant part of a project of that scale, so I wanted to understand whether or not it was entirely possible for me to do a DIY geothermal borehole on my own, without the help of anybody else. I think we are well on our way there. We're not there yet, but with a little bit of modification, we should be able to do it. Over this past weekend, we were able to successfully drill through the top layer of clay. That would be 60 feet of the gumbo that you saw coming out of the borehole, and drilling went extremely well with this unit. It had no issues drilling through that at all. The pump was able to lift those cuttings to the surface and keep the borehole clear. So right now we have a 3.5-inch borehole going down to 60 feet. At 60 feet, that's where things changed, and I believe we've hit a sand and gravel lens. Now, I don't believe that that sand and gravel is continuous for the rest of our boring. I believe it's a thin layer, maybe 5, 10, maybe 15 feet thick, but once we can pierce through that, we should be back into more of that clay gumbo type of material, and drilling should get pretty easy again. So we're gonna have to do a little bit of a different bit for actually drilling through that material, but like I said, once we can get through that and we can get back into that gumbo clay, I believe there's approximately another 100 feet of that clay that we can get through, and that can get us to our target depth of around 120 to 150 feet. That would be ideal for a geothermal ground source heat pump. We would need approximately 7 to 10 wells based on the size and capacity, but I believe if we can do one, we should be able to do them all. So having said that, that is where this series is going to end. I will be providing additional updates as we work through getting through that sand and gravel lens and getting to our depth of 100 plus feet. So thanks for watching, thanks for sticking around. If you haven't already, be sure to like and subscribe, drop a comment below, let me know what you think about the project, and thanks for watching. Guys, I have a quick update here. Since I filmed the outro for the video, I've learned a couple of really key pieces of information relating to what we're trying to do here. So first of all, I managed to find a database that contains drill logs for every well that's been drilled in our neighborhood basically to date. So it's quite extensive, it gives me a lot of detail, and something that it confirms is exactly what we saw when we were drilling. So that first layer from 0 to 60 feet, which was what they call a gray clay, it aligns exactly with what all the drill logs in the area have shown. And then once we get into that 60-foot range, it goes into what they call a gray till. And the gray till is a mixture of that clay along with rocks, stones, round cobble, anywhere from maybe 1 inch up to a couple inches in diameter, and I suspect that's exactly what we ran into at the 60-foot mark as well. That's not the entire story though. Beyond that gray till, they have another layer that they call fractured limestone, and that starts at right around that 80-foot mark. And that's the disappointing part of news that I wasn't really expecting to see. I thought we were going to get back into more of a clay type of arrangement as we drill deeper, but unfortunately, I think that is really the extent of what we're going to be able to potentially drill to, at least in this location. That same database also gives me information at another area, another property that we own, where I also wanted to do a geothermal installation. And in that location, the ground conditions are a lot better. So in that region, they categorize 3 layers. So 0 to 20 feet is what they call brown clay. 20 feet to approximately 70 feet, they have the gray clay, the same thing that we were seeing here, very similar drilling conditions. And then from that 70-ish foot down to 130 foot, they call it white clay. So I think we have a lot better chance of reaching at least 120 feet and getting a real viable geothermal ground loop option at that location. So that might be the first place that I end up doing a proof of concept for an entire system. But having said that, what we ran into here, it doesn't totally bar us from doing a geothermal setup. We could potentially do a hybrid arrangement where we have a mix of vertical boreholes and some horizontal loop to get out to those vertical boreholes. And I think we can still make something quite workable. It's just going to mean a little bit more ground disturbance in the area, a little more excavation, trenching, etc. But we can still get down to some reasonable depths where the temperatures in the ground are a lot more solid and reliable. So thought you might find that interesting. It was quite a surprise to me when I found this database, and at first I was quite disappointed learning that basically we had hit the plateau. We weren't going to be able to go any further, but I'm still trying to look at it with a silver lining that we have a lot of possible outcomes for what we want to do here. So thanks again. We'll see you soon.